Welcome to part 2 of the lecture series on number theory and computations. For this video, we'll be looking at multiples, prime factors, and highest common factors. First, what is a multiple? A multiple of a number is a product of that number and any other natural number. So for example, let us look at the multiples of 4. This would be the product of 4 and any other natural number. And so 4 multiplied by 1, which equals 4, is a multiple of 4. 4 multiplied by 2 yielding 8 is a multiple of 4. 4 multiplied by 3, 12 is a multiple of 4, and so on. And we're opening something else that we did in the previous video when we looked at factors. One way to sort of think of the relationship between multiples and factors is that if 8 is a multiple of 4, then 4 is a factor of 8. Likewise, if 12 is a multiple of 4, then 4 is a factor of 12. And if 12 is a multiple of 3, since by the definitions of multiples, 3 is being multiplied by the natural number 4, then 3 is a factor of 12. And so we see that all the numbers being multiplied on the left-hand side are factors of the numbers on the right-hand side, which are the multiples. The next thing that we'll look at is common factors. And these are basically factors that are common between numbers. For example, if we're looking at the factors of 4 and 6, step 1 would include looking at the factors of 4, which from the previous video we determined as 1, 2, and 4. Then the second step would be to look at the factors of 6, which are 1, 2, 3, and 6. And lastly, by comparing the factors of 4 and 6, we see that the factors common between both numbers are 1 and 2. So let's do another example. What are the common factors of 4 and 8? Well, what are the factors of 8? These are 1, 2, 4, and 8. Step 2, the factors of 4. These are 1, 2, and 4. And so the common factors of 4 and 8 are 1, 2, and 4. And one last example of this type. What are the common factors of 9 and 15? Following the same pattern, we know that the factors of 9 are 1, 3, and 9, while the factors of 15 are 1, 3, 5, and 15. And so the common factors are 1 and 3. This segues into a very important topic in mathematics, highest common factors, or HCF. And like the name suggests, if you have a set of numbers, then the highest common factor is the largest number that is a factor of all of the numbers. So if you go back to the examples that we were doing above, this would mean that the highest common factor of 4 and 8 is 4, since it is the largest factor, or since it is the largest of all the factors. And so if I asked, what was the highest common factor of 20, 36, and 40? Following the same examples that we were doing, we'd find the factors of 20, which are 1, 20, 2, 10, 4, and 5. Then the factors of 36, 1, 36, 2, 18, 3, 12, 4, 9, and 6. And the factors of 40 are 1, 40, 2, 20, 4, 10, 5, and 8. We see that the common factors among all three of these numbers are 1, 2, and 4. And so the highest common factor is 4. Now we're going to take a small break from HCF and look at prime factors for a bit. And a prime factor, like the name suggests, are factors that are prime numbers. So going back to the factors of 4, which are 1, 2, and 4, the only factor that is a prime number is 2. Next, the prime factors of 9, seen as the factors of 9 were 1, 3, and 9, then the only prime factor of 9 is 3. Lastly, the prime factors of 15 are 3 and 5, since they are the only prime numbers among the factors of 15. Now, the great thing about prime factors is that all natural numbers can be written as a product of prime factors. And I'll show you how to do that. Let's start with the number 4. I like to draw a little table like so. Then think of a prime factor that divides into 4. Well, 2. And then we divide 4 by 2. We're left with 2. Then I think of a prime factor that divides into 2. The answer is 2. And 2 goes into itself once. So we're at the end of the table since there is no prime number that divides into 1. We then take the product of the prime numbers on the left side of the table, 2 multiplied by 2, and this is 4 written as a product of prime factors. Let's look at another example. What is 15 written as a product of prime factors? Well, let's draw the table again. What is a prime number that divides exactly into 15? How about 3? And 3 goes into 15 5 times. Now we think about a prime number that divides into 5. Well, the only one that does this is 5, and 5 divided by 5 is 1, and so we're done. We then take the product of all of the prime numbers on the left side, 3 multiplied by 5, 15, written as a product of prime factors. Okay, one more example of this type. What is 36 written as a product of its prime factors? We start with the table and think of a prime number that is a factor of 36. 2, obviously, since 36 is an even number. And 2 goes into 36 18 times. And now, what is a prime factor of 18? Well, 2 works again. And 2 goes into 18 9 times. No. What is a prime number that divides into 9? 3 seems to work. And 9 divided by 3 is 3, so we're left with 3. And the only prime factor of 3 is 3. So 3 divided by 3 is 1. We're at the end of the table. So the product of the prime numbers on the left is 2 multiplied by 2, multiplied by 3, multiplied by 3, which is 36 when you work it out, written as a product of its prime factors. Now, let's circle back to highest common factors. One of the reasons why I wanted to go over prime factors is that when you write numbers as products of their prime factors, it makes it very easy to find the HCF of different numbers, especially if those numbers are very big. And what I mean by this is, let's say I ask you for the highest common factor of 640 and 1050. Those are very big numbers. And if we did the old method I showed you, it would mean that we'd have to cycle through all the factors of 640 and then all the factors of 1050. And that's not very feasible. You know, we're human, we're prone to mistake. So I don't really like doing it this way. An easy solution is to use prime factors, specifically writing numbers as a product of their prime factors. So let's do an example. Let's find the HCF of 15 and 30. Well, using the table, we find 15 as a product of prime factors, which we already determined was 3 multiplied by 5. Now let's find 30 as a product of prime factors. So we drop the table, and we think of what prime number goes exactly into 30, 2. And 30 divided by 2 is 15. Next, let's think of a prime factor of 15, 3. And 3 goes into 15 5 times. And the only prime factor of 5 is 5, so we're done. So 30 as a product of prime factors is 2 multiplied by 3 multiplied by 5. The highest common factor is now the product of all the prime factors that are common between both numbers. So if we look at 15 and 30, we see that we have a 3 common between both numbers, as well as a 5. So the HCF is 3 multiplied by 5, which is 15. Let's do one more example. What is the HCF of 64 and 40? Well, first, let's find 64 written as a product of prime factors. We draw up the table and we realize that 2 is a prime number that divides into 64, leaving 32. Next, we can get another 2 from 32, right? And that leaves 16. Next, a prime factor of 16, would you know it? 2 again. And 16 divided by 2 is 8. Prime factor of 8 is 2. 2 goes into 8 4 times. And by now we should be realizing this pattern as a prime factor. We're going to choose for 4 is 2. And 4 divided by 2 is 2. Lastly, the prime factor of 2 is 2, which leaves us with 2 divided by 2, 1. And we're done. So 64 written as a product of prime factors is 2 multiplied by itself 6 times. Okay, now on to 40. A prime factor that goes into 40 is 2, as it is with all even numbers. 40 divided by 2 is 20. Next, the prime number that divides into 20 is 2. And 20 divided by 2 is 10. Prime factor of 10 that we use next. How about 2 again? And 2 divides into 10 5 times. Now, the only prime factor of 5 is 5. So when we divide 5 by 5, we get 1, and we're done. The highest common factor is now the prime numbers that are common between both numbers when they're written as a product of their prime factors. So we have 2 multiplied by 2 multiplied by 2, and there's no other common number, so the HCF is 8. We've now reached the end of part 2 of the video series on number theory and computations. Click the link somewhere on screen to get to part 3, where we'll be talking about prime factors and lowest common multiples. Subscribe so that you'll never miss a video. And also head over to our website, launchlearningplatform.com, to ask us any questions and also to keep track of your progress.